Okay, when we consider gravitational potential energy, we have it defined as mgy, okay? And it grows with increased distance upward. So we're constricted to choose coordinate systems that point upward. Okay, now a question comes in that the potential energy is a function of position, so the higher I raise it, the more potential it has. And so if I take a ball and I set it on a shelf, it's got more potential energy. Right now, does that mean I'm actually somehow adding energy to it by setting it on a shelf versus setting it on the floor? And we're going to see that it's not so much important what Ug is, what the potential energy is, but the change in potential energy that occurs. So for example, let's draw a system like this. I'm standing holding a ball, no, sorry, very long arm there, holding a ball at arm's length above a pit. And I have a friend who's standing on a ladder, okay, who's viewing me doing this. Now, from this, you can consider a number of different coordinate systems. Now, with this definition of potential energy, we do have to choose up to be positive, okay, but where's our zero? Our zero really is still in our power. So I could see that choosing the bottom of the pit to be 0, that could be a reasonable spot. I could choose the ground where I'm standing to be a reasonable 0. I could use the position of the ball to be 0. Or I could choose the perspective of my friend to be 0. And in each of those cases, though the ball is sitting there in my hand, it says it has a different potential energy, which doesn't make sense. The ball should have the same amount of energy. It's not like I can just change my coordinate system, automatically give it energy. And so it seems like this definition is flawed. But it actually still works, and it's just fine no matter what coordinate system I choose, because the question is, what happens to this energy when I have a change in position? So suppose I drop the ball and the ball goes down to here. Okay. Well, then the initial position was here. The final position is here. And the change in position, I'll call it delta y, is that much. And if I do delta Ug, that would be mgy1 minus mgy0, which becomes just mg delta y. And no matter the coordinate system, I get the same value of the change in potential energy. And the change in potential energy is what gives us a valuable energy. So, for example, I could say delta K is equal to delta U if there's no external work happening. Okay, so this change in potential energy gives me a change in kinetics. So dropping this ball, I would, oh sorry, there should be a minus sign. I forgot my minus sign. Okay, so a loss of potential energy means a gain in kinetic energy. And so we still can choose our origin of our coordinate system, although we're constricted or restricted to choose upward to be positive, because all we care about is the change in the position, giving us a change of potential energy.